quadcopter, a UAV, unmanned aerial vehicle, from scratch. Our basic goal was, since this technology already exists in the marketplace, is to basically find a big problem in a big industry that this technology can solve. The industry is agriculture. The problem is crop loss. There is 4 causes of crop loss right now, major issues. These are 2 issues of crop loss, which are diseases and pests. Basically, this is a graph of corn, which is our biggest industry right here in the United States. Currently, there's 13.9 bushels produced a year, and 1 billion of those bushels are killed due to these specific diseases. At a $5 average rate, that is about $5 billion in annual revenue that they lose every year. This affects farmers, consumers, taxpayers, and insurance companies, because that $5 billion is substituted from farm tax subsidies, which federal government and insurance companies pay down to us. Our solution is to provide an aerial imaging data system paired with a proprietary software which would decrease crop loss by identifying diseases, pests, and water stress. This will increase a farmer's revenue, decrease the tax subsidies, and also basically provide you guys with a stable food source. This is a map of the United States. The brown area is basically, what this shows is that 41% of the United States is farmland. The brown area basically shows that per square mile, that 90% of that area is farmland, where the yellow states that less than 10% of that area is farmland. Currently in the United States, from the census of 2007 to 2009, there is 2 million farms in the United States. 187,000 of those farms are 63% revenue base. Basically, they're bringing 3% revenue to the United States. Our product is the IcropterPresentation4. The IcropterPresentation4 is a quadcopter, basically outfitted with 3 imaging devices: a thermal imager, a near-infrared imager, a digital camera with an FPV system, which is a first-person view system. Our process will be to navigate farms while triggering our imaging devices to capture images simultaneously. This will be paired with our software. Our software will analyze images and provide an NDVI. An NDVI is a normal difference vegetation index, which basically tells you that in a specific area how much live vegetation is there. Our thermal images will identify stress areas by identifying disease, water, and pest issues. With our technology and software, we can create custom flight plans utilizing GPS waypoints with Google Maps. Since it's a major issue in the United States and even the world, there is major competition. One of currently the farmers do is manual scouting, and this is for most smaller farms, which they basically literally go out into the farms, basically visually see if there's any issues out in those farms. This is time intensive, inefficient, and ineffective. Larger farms are hiring scouting companies to do the same process because they don't have the time to, which is definitely cost intensive and basically time intensive. Currently, there is 2 or 3 startups here in the United States right now, with one startup being our major competition, and that's RoboFlight. RoboFlight just acquired 2 months ago AG Pixel and Precision AG. AG Pixel is an imaging system company that basically analyzes images for NDVI. Precision AG is a drone company. Basically, they produce UAVs and quadcopters. With that combination, they'll be basically creating a system that's similar to ours and will basically be in the same marketplace. The University of New Hampshire, they are basically specifically targeting one disease and one specific farm, which is apples. since the most expensive camera on our device is a thermal imager, we decided to do a feasible test, basically to see if this is even worth to be placed on our camera. Here is a plant, basically roses, that we examined with a diseased rose rosette. This is a new disease that came out within a year and a half. On the left-hand side, you can see the plants lined up, grouping with a random diseased and infected plants with healthy plants. On the middle picture, you can see that there's a clear difference between healthy plants and infected plants. The red area shows a higher temperature due to infected plants, while the middle area shows a lighter temperature, lower temperature, due to not being infected. And on the bottom right-hand side, you can see that these are two infected and one healthy plant right next to each other for comparison. So the numbers, the revenue model that we are going to persuade is a leasing model or a rental model for these actual quadcopters. What I based this whole graph on was a 1% share of that 187,000 farms. As you can see on the left-hand side, there's year 1, 2, 3, 4, and 5. Year 1, if we were able to get 1/10 of that 1% share, we would be able to get 187 farms. At a rental fee of $12.50 per quadcopter, we would be basically making by the second year residual every month $233,750. What I mean by second year residual is because the first year we'll be taking our funds from the rental fees and placing it back into the company to basically make quadcopters to distribute to all the newer clients. By our second year annual revenue, we're at $2.8 million. If you want to push forward to the fifth, which is our projected goal for the fifth year, which is to get 1% of that 187,000 farms, we'll be projected to make $2.3 million monthly and $28 million annually. So you're saying these numbers are great. How are we actually going to get to the customers? The number one distribution is crop management systems. Currently, farms have crop management systems installed on their farms now, and they're receiving data from ground sensors. Ground sensors don't, first of all, give you any visual. So these crop management systems have no visual view of any of their farms that they're installed on right now. And what I mean by crop management system, I mean the software. Basically, if we pair with crop management systems, will be an added value to the actual crop management system. One crop management system at this point has 4% farm shares in the United States. And that's just one, and there's hundreds. Our second, sorry what I'd say, but there's 70%, that'll be our 70% sales target. Scouting companies will be our next 20% sales target, which are basically companies that go out and scout for farms. We can lease our products and to them with an effective rate, and they'll basically decrease their time of actually scouting, which will increase their revenue. The third is direct sales. It could be web sales and international. So the most important part, funding. Our initial investment, we need an additional investment of $50,000 to create a functional prototype. To create this prototype, $5,000 will be basically for a hexacopter, which is a 6-rotor quadcopter. Since this technology already exists, that would only take 1 month to produce. The imaging devices are currently out there on the market, and I just spoke with a competitor yesterday with one of the head imaging analyzation companies in the United States, which was actually trying to be bought out by RoboFlight, but denied it. They said $1 million wasn't worth it. But imaging devices are $5,000 without infrared. We're talking about a 5-band dual camera that will be filtering and giving us our NDVI percentages. If we do with $15,000, we'll be getting an extra thermal imager, which will get those diseases. We'll find those water droughts and other pest issues. The software will be $15K for a prototype in 3 months. That's what we've estimated. It may take more. We never know with software. But but basically we're taking already made software and integrating it into one solution. So it shouldn't take too long to do it, so we're not reinventing any wheels. Research and development will probably take K, which will be basically straight towards the software development. Why is the timing now? The timing is now because next year in 2015, the law will pass to actually sell these commercially. Right now, it's illegal to sell to a commercial product. So basically, that's saying that we have 1.5 years to test and create a full product and sign up customers before we actually, the law passes. As below, I added a video of one of the customers or potential customers that we spoke with. Fred May, he's a farm out in Quincy. He has about 250 plus acres of nurseries. And this is basically, he's categorized as a small farmer.
This is your quadcopter y'all were testing.
This is my quadcopter.
And the other photos were, the infrared were photos y'all took?
We took, these are all images that we personally took, and these are all pictures that, everything is ours. These are actually, there are 4 brothers that own the farm. They've been out there for about more than 4 years. I don't think there's any sound right now. So basically, we're actually going over, these are actually rose bushes, but they grow at a certain length before they actually settle. So this is actually, we're going up in the air and actually showing how piece of, this is only one plot of his farm. So he has multiple plots of different areas. These are our contacts.
Those people you actually met with?
Met with, spoke with, basically primary research. Anybody have any questions?
I'm willing to bet $20 that none of you guys have a biology background.
No, but I did work with a plant pathologist.
Do I win my bet? Do one of the 3 of you have a biology background? No. Okay. Good presentation, very logical, good homework, well presented. I'll challenge you with a comment. What you've done is found a diagnostic tool, but you haven't shown that by early diagnosis you could intervene and prevent the crop loss.
Yes.
Okay? But you've assumed that.
Well,
and what I'm saying is, depending on the resolution of your camera and the type of disease, by the time you note that it's embedded in a crop, it might be too late. It's all over, it spreads so fast, it's beyond the point at which you can control it. That's only a comment on this because if I understood it, you go back into the farmer and pose to them a cost which is related to their gross receipts of the crop, right? Okay. I would suggest back to you a second comment, which is that the farmer will see you as an input to the crop. I want to pay so much for fertilizer, it's a fixed cost, I know what it is. You got a diagnostic tool, I'll pay you X bucks as opposed to X percent. So I would perhaps ask you to go back and look at your revenue model. But again, diagnosis up front is probably 40% of the prevention. And you guys didn't build this during this class time, right? This is a project built.
No,
this is all been done during this class.
Really?
Yeah, they basically looked at the engineering project and said they're working on something that already exists, and then they ideated how to take what's already existed. So they started from scratch.
Did you build this device?
No, this one is not built because I didn't have time to actually build it from scratch, but I purchased a consumer grade one, and I attach my cameras to it.
All right, quick question for you. I think in the presentation is correct. You assumed that. Now, I have a little more information than I did. So answer the question. Does early detection of a disease in part of the field allow the farmer to dramatically affect crop disease?
Due to crop scouting, we are probably maybe 40 to 50% more efficient than manually scouting.
But
we can detect a disease prior than most crop scouting companies can. Earlier.
So what you're still by implication saying it, but one of the things that'd be really good to have in the slide, because I think you got a good idea here, is the fact that the reason there's a crop scouting industry is that early detection allows them to deploy insecticides, pesticides in a more targeted way.
Correct.
And keep the crop from being destroyed. Is that correct?
Exactly.
You got any statistics on early detection versus later detection or any of those things?
The only research we have is from the actual plant pathologists over at the IFAS, which basically said they isolate plants prior by maybe once they can be a couple weeks even, would avoid from spreading to other places.
Okay, so that would be a really good point, John, very well. Second thing is, you talked some actual customers.
Yes.
The hunt brothers. What did they say about it? Did they say they'd rent one for,
Well, these are the May brothers.
Yeah,
May
okay.
brothers. These guys, actually, yes, they would definitely purchase one to use, because they want to use it for all types of issues, which is due for diseases, and to actually monitor their crop on a daily basis.
so have you talked to any other farmers? Now, tell them a little bit about the grant request that
Well, currently we're working on a grant with UF that is going to provide us with around $35,000 to make a prototype of this device.
So how did that come about?
I work with the plant pathologist over at the UF IFAS, and basically they're not utilizing any of this type of technology, and they want to use it as soon as possible, basically. So basically I'll be outsourced right now to create a consumer grade for them. Once we do that, I'll create a commercial grade.
In spite of my comments, I take a very serious look at investing personally in this.
Okay, good job, guys. Now, you had a little long, but you got a lot closer. So any other questions, class?
I had one.
Yeah.
Where'd you get the $12.50 a month price point from?
$12.50 a month. I calculated that because a machine will cost around $15K a year. I mean, $15,000 to develop total with all the cameras. So I said within a year we can get a payback on the actual device, and basically if we sign a 3 to 5 year contract, we can basically make our money in year 2, 3, and so forth.
So we got an accounting major over there, ran some numbers on this. And all of you guys are actively involved in this. Yeah.
If they're gonna lease it for more than a year, then why would they just buy it themselves for $15,000?
Because then we won't get the support. We're going to be providing the software support and the actual.
So the software is where the real value is.
Well, put it this way, if you can get recurring revenue, it's worth a lot more money. So,
And if they break something, they won't get it.
so they're leading that way. Yeah.
So you guys actually changed the original patent, or
There was no original pad.
but it's your own spin on it. Is what I was asking. So it's open for investing. It's not like controlled by the school. They have a
Nothing
license.
controlled by
and
the
everything.
Yeah. So, you guys and scenery, we gotta talk after semester go, because we need to get you an incubation. You guys, Ron, you didn't see it yesterday, or Tuesday, but there's another very interesting thing. Very good, guys.